right? So Proxmox right now, it's an interesting time. I talk to customers, prospective customers every day, practically, about using open source mid-range on-premise virtualization, maybe bigger than mid-range. This isn't it, right? So here I want to talk about literally just how do you start? How do you overcome this barrier to entry into some kind of a home lab maybe, or a POC somewhere or such, right? To do that, I want to take you on a quick memory lane. Also, thank you for not curating my talk. So I started the company a little over 30 years ago, just because I wanted to get to the point where you don't have to beg to be able to do technical work, and that's been working so far. My first SAM that I touched was a DEC StorageWorks HSZ40. Anybody remember that? Yes. Okay. Data General, later known as EMC Clarion. Yeah. DGC. Yep. So that was kind of what I started with, SGI and other things, and we've worked in practically everything. I think Anthony calls me an integrator, and that's true. Integrators care about basically stuff that works. All right, whatever we put together, it's got to work. We started doing some hosting around 2013, and I had this really good experience before with basically going to open source and things just work, right? And that was nice. So we've put together appliances based on various Linux distributions, and you just plug them in and things happen, right? And that was pretty awesome. So I was looking to do that with storage. Found Ceph, met Sage, and that's good, right? And then where do you go from there, right? So where you go is you start getting your hands dirty, right? And again, this talk is about getting your hands dirty. No matter at which hardware or budget level you are, whether you're at home or you're in an office doing a POC or whatever, right? How do you get started? So I tend to go overboard with everything, right? So I got started with a lab. I'll show you a picture real quick. So this is in my house in 2013. This is guys loading a 38 kilowatt backup generator into my house. It got out of hand very quickly. But for about 2 weeks, I think I had the fastest Ceph cluster in the world. 2014, because I built it with old flash, it didn't last long. But the point is, okay, so I built it out of hardware. So you take machines, you put them in a rack, get into trouble with family, and it works, right? But couldn't there be a better way, right? And we got things out of this. It ran fine. It was a very good POC for pretty much everything we did after that. I moved the lab; it's still there. It's in the normal data center now, of course. We actually certified it with VMware at some point, because VMware was virtualization, back then, and we got on the HCL. It was an enormously painful experience, although successful. And what I got out of it is a deep dislike for T10-based protocols. So iSCSI, fiber channel, regular SCSI, and SAS is serial attached SCSI. So all of those, I realized just how wonky they are underneath. We still use them. Probably most of mid-range still runs on them, but it's just really painful. Whereas Ceph, and of course Sage is a mathematician. A lot of things are structured, right? So RAID, reliable autonomic distributed object store. RBD is a RAID block device. So kind of wrapping that acronym further, and it's a really nice protocol for storage, because you don't have to deal with LUN masking or zoning. Right, so none of that presentation stuff, and everything's built in, trim's built in, it just works. So it's a nice, it's a nicer thing to do. But anyway, so what do you do instead of this? So Proxmox, actually, Ceph is 20 years old, so is Proxmox. Proxmox is an Austrian company. They built an open source hypervisor, basically back in 20 years ago. Pretty much nobody cared up until last year that they existed. We've used them. We've used them as POCs. We've used them as built-in, basically a hypervisor solution. The nice thing about it is it works natively with Ceph, right? So you can use Ceph storage directly in it. They've gone on to develop basically their own orchestrator, right? So it's built in. Everything Proxmox does is very practical. It's very kind of, dumbed down is probably not the right word, but that's what comes to mind. So it's very much plug and play, and it will work immediately. So it is GPL'd, a Affero GPL, so it's free as in free, right? So you can run something called a no subscription repository there, with no, reduction in functionality or time limit or whatever. You can just run it. We don't typically recommend doing that in, large production environments because there's basically no throat to choke at all. But for a lab, it's perfectly fine. And to get started, that's perfectly fine. If you want to run that home server, there it is. It's very reliable. It runs on Debian Linux. Proxmox provides their own kernel, but it's Debian underneath. You can load stuff in it. You can run, processes. You can log into it, with SSH and do things. So absolutely fine. Natively, it'll run VMs. So your Windows VMs, Linux VMs, Lexi containers, which are, it's nice capability to do that. We have gone as far as to basically load Kubernetes in there and run Proxmox VMs as Kubernetes nodes, and that runs fine as well. Running Proxmox with external Ceph clusters, if you want to do that, is perfectly fine as well, right? It's very clean. They stay up to date. Even a little kind of too much, right? They're very, very up to date. I'm scared to go to the latest version than they do. Right, and so you could ask, well, okay, so what are these people? How do they make money? Well, they, like everybody, open source, right, on support, subscriptions, that kind of stuff. But what distinguishes Proxmox is that you can absolutely, like I said, just run it for free. Just load the no subscription repository, get started, that's it. All right. So also very nice user community, so really good wiki. If you want to do something, you just Google. You could absolutely make a profession out of Googling Proxmox, and then giving that as advice to people because it works very well. And then RBD and CephFS are built in. RGW is not built in, but it's native Ceph, so if you want to run RGW, if you want to do object out of it, then you can. Okay, and then if you've connected ever to a Ceph cluster, you do it through keyring and caps. Caps are capabilities like permissions, right? So you basically set up a user, get a keyring, with the capabilities that you want. You can put it into Proxmox. You're done. Right? There's your storage. Multipathing is built in. So there's provisioning is built in. You pretty much other than managing failures, you can administer all the storage right from the hypervisor. All right, there's we have an engineer who really wanted to set up a lab, so we said, okay, go buy something. He bought mini PCs, with little hard drives, running that perfectly fine. Okay, I'll show you VM snapshots momentarily. Hopefully I'll be able to just hop into the lab. I do have backup slides. As any operational integrations person, I have my plan B, plan C, second laptop. And hopefully we don't need any of that. And then at some point they built a backup server, and I've worked with a lot of different backup technology over the years. This is really cool. This is good stuff. Same thing, same GPL. Can run for free with no subscription repository to get started, run a lab, whatever. But it has deduplication built in, very reminiscent of Borg, if anybody worked with Borg. And KVM, which is Proxmox, uses QEMU KVM hypervisor technology underneath, open source hypervisor. And that has a capability called change block tracking. which is, sorry, it's called dirty bit mapping, but VMware calls it change block tracking. It's the same thing, basically. Where the VM, actually the hypervisor, keeps track of the blocks that are modified, dirty blocks. And then if you are running a backup, then you just need to deal with those, right? Which is a very efficient backup. Okay, so instead of this, hopefully I can just hop in right into the lab here, show it to you live. So this is what Proxmox looks like. So you install it. I got a cluster here. So Proxmox clusters are, with Ceph are basically two clusters on the same hardware, right? So you got a CoreOSync-based Proxmox cluster, and then you got a Ceph cluster. And they just happen to run on the same boxes if hyperconverged, right? So here's one of those. So you got your VMs. Yeah, you can do live migration. You can see there's some RGW VMs running Ceph Gateway. So you can do live migration. You can make snapshots, which are going to be Ceph snapshots, and safe as well. If you're doing some kind of scary operation like patching or whatever, you can take snapshot, right? And snapshot happens. And there you go. So I can revert in case something goes south. And then you got virtual hardware. So here's a Ceph. This happens to be an NVMe tier here. And, that's pretty much it. You can just add storage to it, move it, and so on. Creating a hard drive on Ceph. Again, I'm not even touching the Ceph cluster directly, right? I don't need to do anything to it. It's all here. So there's some storage, and that's it. You can manage the hyperconverged Ceph right here. So here's a cluster. It has a cute little GUI. There's OSDs. So, pretty much everything I've ever done in Proxmox is triple replicated, right? And it works wonderfully. And, VMs, you typically want low latency, good IOPS. So here's a couple of tiers here, so you can separate them very easily. In the Crush map, Crush is controlled replication under scalable hashing. That's basically the mapping of things inside Ceph. And here we have a 1 terabyte NVMe class, and then we have a 4 terabyte NVMe class. And you can separate them by that class, and they're just assigned to different pools. So we have a pool for this type, this class, and a pool for this type, and then you do whatever you want with them with storage. Okay. And then there's some really nice bells and whistles. So the Proxmox backup server, that's what it looks like. Again, you pretty much don't need to talk to it once you set it up. Just go to Proxmox, set up storage. And by the way, all of this stuff is text files in the Debian system underneath. So you can just go there and deal with all this in command line. So here I have a session open, right? This is the atomically synchronized file system called PMXFS. It's based on CoreOSync, which is a messaging mechanism used in clusters. So storage is really just this, just a text file. Yeah, you can interact with it just like with sysfs. So you can write things into it and parse it and do whatever you want. VMs are much the same, right? So if we look at a VM config, it's just this, right? So you got control, over your virtual hardware. You could do it from the UI, you could do it from here, you could do it with the RESTful API that they have. You could do it in command line, pretty much. Whatever floats your boat. All right, and then, like I said, all of this stuff is defined as storage, and Proxmox also calls these storages. And so you have a type of storage that's RBD, that's Ceph, and then you have a type of storage that's Proxmox, right? So you get something like this, and there's storage. You can do encryption on the fly, so it's all built in, right? All with a no subscription, basically. Run it all for free. Again, this isn't, something else where there's feature lock-in and so on. Run backups encrypted. That way you keep the encryption key, don't lose it. Send it to Proxmox backup server. That can replicate to another Proxmox backup server. So right here you have your, so I'm actually replicating this out of Rockville, Maryland into Manchester, New Hampshire. And then I can recover from Rockville, from Manchester, whatever you want. Right, so replication can be every 15 minutes or so. So it's asynchronous, but you can make it fairly frequent. So pretty good. It's very much enterprise grade in summary, and you can run this anywhere. And this will scale very well from small footprint hardware to a large footprint hardware. Okay, that's pretty much it. Ask any questions, and go for it. Yeah.
Oh, God, please, I'll yield. Go.